Okay, lovely people. Let's go over the ring here. This is the starboard side, so you can see the identifiers they put on here. That's the bottom interface ring. There's some electrical there, connections there. And let's go up a little bit. And here's the dome, the front dome with the window is supposed to be in it. There's the starboard side, so port side's over, yeah. Port side's over here. So port side's your left side. So that would be the bottom. Yep, indicated there. But as you look in here, you see witness marks, scarring. Remember I said that this came inwards first. It didn't just blow out. It came inwards first to do what it had to do. And then it did a reversal. Oh, there's some material. There's some material right there. There's the material right there. All right, now you can argue that it blew material into it. But remember, this had a hell of a pressure on it. A car going down underwater, right? A vehicle going down underwater, you can't open the door because it's going down, and as it's going down, PSI is increasing on it. The water inside, even if the car filled up, it's still not equal with the pressure outside. So you still can't open the door. It's too much PSI on it, depending on how fast it's accelerating to the next PSI level. If you could have it way down to, I don't know, it would be very small PSI for you to do that. But as it's going down, you can't open the door. Same thing with the Titan. It has these two ends, right? It's only one end that's open. But these can't come off because the pressure is locking them in. It puts this in compression here. This is a compression. This is where you would worry about buckling the cylinder area here. I'm going to delete that part. So that's where you worry about buckling the cylinder. I want to introduce you to punching shear now, again, of all things, punching shear. And I want you to think of the water, number 6. Number 6 is our indicator that it's really fired up. Now that was not the last, as I said yesterday in the video, someone told me that no, it did 88 dives. Well, doing research, I think, AI says it did 90 dives. So apparently we don't have its depth sentence. The depth sentence that this ship was, this vessel was giving us was many dives before. So some people argue, well, why didn't it work? It did work. It told him it was broken up, but he still continued to dive it. Back to this center part here. Number 6 is at the top. This is look at 6 bird's eye view. Imagine here is the sensor, and it's picking up in this frequency like that all around it. And here's the top view, and so it's picking up radially signals. Now imagine that since this is weak here, and I don't know how far that signal goes out. I know it doesn't go down to let's destroy it, to the 250 degree one. That's number 7 right here, the sensor, this one. And this is number 6 at the top at the 0 degree angle, right? So 0. And so this sensor didn't change. So this radio reading doesn't make its way down to here, because 7 is pretty tame. But 6 is pretty lit up. So it's going to be more, the closer you are to it, the more to damage to 6, the higher the fracture is going to be. But it looked like it went right into really panic mode and identifying itself with issues. So I want to show you initially when you hear sound from 6, how this, even though I showed you radially there, let's do this. Oh, it won't let me clean it out anymore. So there we go. So let's do 6. So here's a top view of the vessel. This is number 6, the sensor. All right, when you hear initially you see the graph bar, right? You saw it all lit up. Well, that noise could be coming from way over here. And as it gets closer to the 6, it gets louder. You see the frequency raised higher. Now I'm doing it linearly like this, but it could be radially, you know, going out this way, and so that's why the number two, that the number 7 at 250 degrees matters to me. And then over here was, I don't recall, I think no 4 was somewhere. Yeah, I forget what this one is. Maybe it's 5 and it's not awake. You know, one couple of them are loose, but it doesn't show. It's not reading up there at the top. So why the top of the vessel weak? If it's a cylinder, it's equal all the way around. So it shouldn't have a weak point at 6 unless one was created somehow. Remember the belly of the beast. This thing was transported. I'm just making legs up like that. So it had about an 8-foot span, unsupported span, that it had to hold itself together, and they towed it out. Well, this thing, if any deflection happened, rowboating, it would. Here's number 7, right down here. It would dip down, and this is what the guy showed in one of his drawings. The problem with his drawing is that if this dipped down, what I just said, number 7 should light up something. So 7 is not showing this deflection issue, unless by chance number 7 broke all apart and it couldn't read anything else and calmed down. And this is a compressive moment here. This one is in compression, that if it was doing this dip like this. And that's where they show the rings, the rings that they're implying, and that they're rotating in like a hammock. Remember, you got this huge ass weight back here, though. The rear of the vessel. Up here, we just have the dome, mostly in shear plane with the bolts, clamp portion of the bolts. Also, the force of the water holding it in. All right, there's some reduction, I think, with the pressure acting in friction in that capacity. Back here is the dome. The dome is here. It also has the same thing going on as the front dome. So they're trying to claim that it could do that. It could hammock. If it was hammocking like that, I think 7 would pick up some noise. It did not. It did not. And besides, it has to get shorter. And this would be compression. This would be the buckling point. It would if it could hammock like that, it would fold. It's like you putting a paper towel shit roller, right? The toilet paper roller, and you press it on each end. Okay, just don't try to crush it, but press it on each end. Great. Now with that toilet paper roller in the mid span, somewhere you pick your poison, just perforate it a little bit with your fingernails. You know, push on it. You know, and crease it, and now put pressure on it. And you'll see that that's the place it's going to begin to buckle. This toilet paper roller is here. This is 6. 6. Now, why is 6? The question is, why would 6? Why is 6 so up the top? So interesting that it could be that. Well, we don't know because we don't actually know what they were doing previous to that. One of my theories that during this failure, there's only one strap here and one bolt holding onto the interface ring in the rear, holding this vessel here, and then it comes back. And I did multiple videos on a bracket that's here, that's holding this, that's bracketed, and then it's down the legs here like this. It's just a small bracket. All right, bracket. All right, how about like that, if you can see it better? It's just a small bracket holding this holding it that way, and at the very top, there is this. So this would be here. 1 pin. The bracket has 1, 2, 3 fasteners in it. They've changed it so many iterations that they went through 4 iterations of that. The latest bracket has a part number to it for quick releasing the skids. So the skids, these are skids down here, and the legs. So you release the legs, to release the skids, you release the legs, I believe. So why that? If it's pulling on that, remember they dropped the weights at the last moment. We know they dropped 2 weights, and that's the last time we hear from them. The drop weights. So the weights are on the belly. Did it roll? Did it hit something down there and let it break free? Now the other problem is I don't know how you drop the skids. They had the guy who was supposed to come I think tomorrow. He's going to talk about the electronics. I think about how that worked. I think Tony did that, or was it the electrician that made up some cheap mechanical version of how to make the weights roll out onto the at a position. Now we do have compression going on just because of the greater pressure down there. And then we have relaxation. But it's at the very top. It's not, here's the radius, right? It's not everywhere because the forces are everywhere as you go down. Now there's a minor gradation, meaning that at the top of the vessel to the bottom of the vessel, there's different PSI. You know, I'm just giving it to you for getting into the weeds, if you will. But back to why punching shear, if you will, of water coming in here causing 6. 6 is definitely our beginning failure point. And we would need to see, I need to see more of the graphing, as I pointed out, and I'll link it in the video where I talk about the graphing. It could be way out here is where you first hear it, right? The weakness. But that's across the top. It could be this direction too, where it quite doesn't make it to 7. 7 is positioned, I'm going to do it one more time. So 7 is positioned here at 250. Here's 0 degrees, right? This is 90. Yeah, they went counterclockwise. So here's your 180. Here's 250 degrees. This is your 7. And I show that. And it's only one, maybe the sensor I care about is ×1. And at 0 position at the top, in the middle, top middle is 6. So middle of this top, 6 is firing up. It can only be so far radially around this section here before it picks up 1.7. And so I know it didn't make it quite to 7. So I get to choose some poison here. And this one down here, I think, is not reading. I don't recall that. No, I don't recall this one reading. I did a video with you guys. I don't remember if that's number 8 or not. Doesn't matter. It's maybe that's the loose connect one. Maybe that's 5. But this one was connected. This is 7. I see a small frequency in 7, and we see a small frequency like that. And number 6, oh shit. If I delete this video by mistake. And number 6, we just see it just gone hell wire all the way across. So let me pause this and see if I can fix that screen. So number 6 it looks like that, and they're at the bottom. They're at the 30, let's say 600 meter mark below sea level. And number 6 is not down to number 7. So wherever it's doing, it's this way. So it could be up here. 7's not picking up on it. So I'm still thinking very top. And my bias now would be that they had a band across there. They connected the back interface ring with the front interface ring, forward, aft. And let's say this is the aft. That's the tail end. There was a band going across. And there's your bolt of connection, and your top of your vessel. Single bolt. If this thing went in shear, like he's showing expansion and contraction, well, this steel, depending on how rigid it is, including this steel, is working this bolt. We have a single bolt back there. It's working it. So it's pushing. When they're driving down the road, it's wrapped around it, right? So it's an eyelet like this. And it didn't fail, incidentally. I showed that in the video that this is not torn apart. Yet it was a bolt in it. So it sheared the bolt. And so this circle here, that bolt must have been very soft because it didn't even elongate this. And as I recall, I talked about quality. Let's look at this from the top view. That hole wasn't even centered. It was off center. I said, wow, that's Tony's quality control, I believe. And ultimately he's responsible. I mean, why would you put that thing off center? So that tells you the whole rig is off center. If this bolt is off center, then the whole thing's off center. And they didn't have a way to indicate correctly to get it squared. So now we have this bolt I'm talking about here, going back and forth. It was numerous times that this thing comes up head eyeball first, right? Lens first. I call it a lens. They call it a window. Lens first, which of course the back end is off here like this. It's got that bolt. That bolt here. Let's change colors again. That bolt here being pulled. It's pulling the back end up at that point. It's pulling it up. And that's also with this mid bracket system here. It's like that with the legs, all right? It's pulling it up. Now across that bracket is also a strap. I'm going to show you remember the strap. This is critical, this strap, because this strap will take on a buckling. And now to that strap is connected right there, the door hinge, also the gear to drop off. When this implosion happened, this punching shear took place, it allowed these to fold in, I believe, right? So come in like that, forcing all the load back here in the rear. This landing gear, which I'll show you, pushed this piece of metal inwards, buckling it. Let's get to that. So this is that, and I don't know if it's one image up or not. Let me come up. Let me pause. No pause. So there's that. Believe what it's there. Now I called it. I called the SGT. I think stands for segment when you see it in the mapping. Segment 1, 2, and segment 3 they call it. That's that piece that buckles that strap. I think we're looking at there. Although, so they're saying this is the bottom of the hull, so this would be the contrary, and this is the top. But recall, 6 is at the top. If this is the bottom of the hull, why do I see such a beautiful piece of carbon fiber right in my way of number 6? It's in my way. The bottom is the part that's missing out now. So if we clean this up, the bottom of the hull is what's gouged out, right? The bottom. This bottom, the top is here. And yet, contrary to this image, 6 is this should be fractured. That would be the weakest point. It was the most noise coming out of 6, which indicates it's the either somehow magically the most censored, that it could read better than anything else. I doubt that. It doesn't match with the other sensors that were before 6, meaning intercepting 6. We have sensors on the ring, front and aft, forward and aft, and then we have the 6 up here. We got 7 down here. And so I don't see in the sensors. So no, that puts it in the middle third area, or starting from here, working its way back to there where it gets louder. But that one dive was just totally freaked out. It was all the way across fractured. So this settled down, meaning that there was nothing else to fracture anymore when it entered the depths, when you see it flatline. So it couldn't get a reading anymore. It couldn't fracture anymore. Back to the image, this is indicated as bottom, but this piece here, I showed you in a video that was the bottom. The lifting section was the other way. So I don't know if I agree with that, with their orientation. Let's go to this. So this is your starboard ring. This is the curlicue, right? This means that the carbon fiber spun it out as the forces of water came in. They caused a rotation, and it spun it out. As you can see that, that's Max in the background. It spun it out, and in fact, there's another piece of it, piece of material there. This is indicated as the bottom. So I think this should be segment. In the drawings, when we look for segments, they call it, forward segment, discovery with forward end. So just so you guys know, I do videos off the cuff. I don't, I let you get my brain as we look at it, as you look at the images. So pre-existing separation, it's the back tail. What I mean by that is there's a, what I could, in one of the videos I said, I think they remove it and don't dive with it because it acts like a sea anchor. They had this cone back here in design with a little bit, I'm sorry, let's do it like this because it had a little hole in the back right there. So this will be like that. Water, theoretically, it was creating drag, I think. And so they were like, you know what, just get rid of that shit. you know, when they're moving around, they just pulled it off. We already went over that image, so we won't beat that again. So back to this again, hull piece B, but the you're seeing that I thought they did it, you know, theorized, and they did it in like 3 lifts. They did this in 1-inch lifts, from what I understand now. So they did lifts, meaning what layers. And Jeff Ostroff in the comments there tried to correct me, saying that you can't get, when I told people that you'll get cold joints when you do these multiple joints. And Jeff Ostroff wrote, he didn't, you know, say my name. He's too embarrassed to say my name. He said that no, it doesn't create cold joints. And I said, every time you stop manufacturing of anything, you're creating a cold joint. All right, you're creating a joint where you can get hold of it, where you can find it, discover it. In this case, they created 5 cold joints. And now between each layer, you're looking at the epoxy, and the epoxy coloration looks like this. It looks like that bluish. All right, so there is my outside piece, I believe. They say hull piece B. This is the part that was connected to the legs, and I believe you're looking at the buckling of it. So there's another image I saw, somebody showed me, they sent me. So I'm going to look for the other side. This image is much more clear than I had before. So right now we're dealing with punching shear at 6. I'm just going to say punch shear, it pisses people off. Punch shear at number 6 zone. Okay, and then I'm going with buckling here. So this is buckling. It took place. And hopefully I can get a screenshot of it. Okay, good. Let me clean that up. So and there we go. That's interesting. It's very interesting. You can see it torn off right there. There are the holes that they used to screw the cowling on right there. They had rivets. And if we look at it, it's ejected. Now, I don't see any bladder on this one. Like that. Going back looking at that ring, saying that's the bottom. I mean, I don't see it strapped to it. Very well could be the bottom. Very well could be the bottom. And 6 then would be, even though they said 6 was at the top, 6 could be over a little bit. 6 could be here. Number 6, because remember, they haven't verified the location. So 6, instead of being a 0, it's indicated as 0, but the as-built, if you will, is 6 over here. I would find it very difficult for 6 to be in plane with that, and the failure starts somewhere else. I'd argue that 6 was down at the bottom then. That instead of 6 being at the top, that they had 6 inverted, even though they said it would be at 0 position, which is the top of the hull. I think it's at the 180 mark. That's just a thought. Just because I don't think you can get that much noise and have this much stable material, and presently it failed this direction, which would be the bottom. Now that's their version of showing bottom. This would be my version of proof it's the bottom. Is that giant nut that goes all the way through? So let's go from there. Oh, 100 meters. All right, now we have, it says, they call it the port rail. Let me see, yes. So port rail right here. And now there's buckling, right? But it's going to be a better version of buckling. I remember the image. Let's see, starboard. Again, I'm doing this with you. I haven't seen this one. I'll tell you when I've seen the image. I haven't seen this clarity. Okay, that's beautiful. All right, starboard. Oh, so port is left, starboard is on your right. Just think of PS, like you write somebody, PS, I'll talk to you later on. So PS in that order. Port PS to the left on the PS symbol. So port is to your left, starboard is to your right. So when they say starboard, that would be the starboard side there in the middle. That would be the starboard, the right side of the vessel if you're looking at it from as you were driving it, looking at it. Let's see, that's the rear. So yeah, so you're looking at it from the bird's eye view down. The rear would be behind you with the tail, and that would be the right side. And there's the nut. All right, so there's this huge nut that goes through both sides, and that's how you enter this. Now there's a spiral here, so there's the tear of it. The tear of it. Now that tear clearly is on the back side, meaning on this side of the ring. That rip you see. So it broke free, and like a can opener, the dome, it didn't just slide off like you're looking at. If it did, we wouldn't have this curlicue like this. No, it didn't just slide off. It got sheared off by the force pulling it down using this carbon fiber titanium ring. Carbon fiber. I guess I thought of the edge of the beam blacking, so carbon fiber. All right, so they did have the lifting, the salvage hooks on it. It says top over there. Let's see what else I can glean from this. It fractures in awesome pieces. We're looking at the pieces all consolidated. In fact, you can see that it's shear plane. Look, like this. It's shelved it. So that is it broke apart the layers. So the layers became so rigid during manufacturing. Once they finished, they became so rigid they even don't bond. Because look how you can get it shelved, if you will, like bookcased, like that. So that tells me that this, in real world, carbon fiber will never, the layers will never bond. Once it sets, they're not bonding together, because otherwise it would just break clean like a piece of like a cinder block or something. But this allowed that bypass to take place. Let's use the NTSB's guy's wording. He called it rubbing. Yeah, I wouldn't describe it as rubbing, but he does. So let's go with that. Now, this appears to be a trading of materials, metal. And then we have part of the... Oh, this is interesting. So we need to track down this. This is stuff that they need to ask Tony about. Saying, Tony, what's this? What's this piece here? He would know. He'd go, that's the whatever valve or something. He'd blow it up or something. And what's this, Tony? What am I exactly looking at? And he might go, no, that's not the fiberglass. Well, when they bring it up, they'll know if it's fiberglass or carbon fiber. Then you could tell whether it's part of the cowling or not. I've heard the guy that's just sub channel does subs. He said that's how it's imprinted from the cowlings. I'm like, no, it didn't imprint itself from the cowlings. So we're looking at the layers again, and if this is true, that's only 1 inch layer. So a zoom lens, just so you know, a zoom lens, when you zoom in, so if you're picking a picture of your girl and you want her to look nice, don't use a zoom lens. Never zoom in on a girl's face. Unless she's a real thin girl, you'll blow her face up. But a football player, you want him to look good, you get a 200 millimeter zoom lens, and you step back and you take his portrait with that. His jawbone, his face, everything would look much bigger and square and strong. So I got to be careful what we see is what's zoomed or not. And I think I know what I'm looking at here now. What, do you guys figured it out yet? Have you figured it out yet? This is for Zachary. Zachary, it's green. That's green. I believe they use green oxygen bottles in this, and I theorized that it went back there, and there we go. They're green bottles. I think that's them. I think that's your green oxygen bottles, which was kind of, yeah, that makes sense. That would be the bottom then, because they're at the bottom. Then that would be the top. So the bottles, there they are. The bottles, wow, the bottles are amazing. They're on the outside of that ring. I'm going to process again a little longer. I'm not going to waste my time with you now. But what I do is I put the data in my brain. And the way I work is I have problems sleeping. I got to take meds to go to sleep. My brain won't shut off. It'll process. I just tell myself, it's weird how I can do this, my process. I can say, process that. Tell me what that bottle, put it together, and I won't waste my energy on it now. And then while I'm doing something through the day, this will be working in the background like a damn fucking second hard drive computer running in my head. It'll be working in the background till it comes up with the answer. I'll take notes like this appears and presents as folded over. Definitely folded over, but it's pushed to the rear, not out. And obviously, it did not break the carbon fiber at the top. So the implosion forces didn't just go from the bottom and up to the roof, or the roof will be bent over. The roof is flat. So think of this as the underside again, punching shear. It goes two directions, so the forces go this way and this way, but at the same time, as they're going to the left, we still have that outside force of the water pressure. So it says this pressure that's coming in, it now sees it weak, it causes buckling, and it says, fuck you, and the front part of the vessel drives in. It drives inward towards here and then rebounds out. It buckles what you see here is called the port rail. It buckles that. Let's see if we can get a better image. Let's see how lucky we get. It says top rail. Okay. And that looks like you can see the carbon fiber on it, the gray on it still. Looking back there to the right, looking at what I call this might be the tank. Looking at what they call the top rail. So, okay, this is very, very good data here. So here is the carbon fiber hull, and as you see, it's not actually in the same position as it was around the ring. Look here. I'm going to do the ring now. Look there. There's the glue. That's the glue on the ring. So this carbon fiber pushed in, or this whole thing is rotated, spun around, and we're looking at the bottom and not the top, because that would still give us number 6. And it's spun around in a full 360, the carbon fiber shell part, because that's a full break. I was hoping to see it locked in place, and that would take apart that theory. Because it was locked in place, that would tell that. Let's see if we might find an image. If any of that carbon, if this big section was locked in place, it didn't spin. But something's holding it in off the deck also, so. But it's broken off. And layers, no more image I can't get. So we'll process that. We'll run it through the processor. Here we go. So this is top. Okay, I think I got my orientation already. So here's that rail, the top rail. Remember the way it looks. I'm going to show it to you down here already. And yeah, it says top. Well, it says top, but it doesn't say top rail. That's this one. There's that carbon fiber ring I talk about. And there's the glue. It's more glue indicating that it left glue behind and broke bond. Not with the titanium, but with the carbon fiber. Here's my beautiful piece. That's that port, as they call it, starboard side. There it is. There's the buckle. I'm sorry. There's it buckling there, and then buckling here. I thought there was another buckle here, as I saw with the when they cruised around with the vessel. And the holes are how they screwed into the cowling on it, this side cowling. And since it's the back side of it, and we see holes on the other side, appears they use nuts and bolts. So, because it's all we own, but we never got to see the other side in any of the images. It was painted blue, and now the revealed color is this. I don't think it's a trade-off of materials and you get a different color. This, I think, is the skids, or the skids now. The skids came in and bent it, not the dome on this one. I think this titanium ring, rather. I'm sorry. They call it segment, whatever segment they call it. Front segment. This would be front segment. Interface ring. So, yeah, it came in and it went to the left because it buckled it all to the left. So now we have, it started here, and let me put that so you can see it like that. That's this piece. This is. It started in that position, but it shifted left this way because this is out here to the left. And then maybe it rolled that direction and went off that way. So we'd look for that. If we can map it, we'd see maybe the ring on towards the left of this image. Again, looking at the carbon fiber down there. Yeah, it's debonded around the entire ring. and not much buckling. Remember we talked about buckling? Well, this isn't. This is just some slippage off that number one. This could count as buckling because it's missing a big section here. But that would only be on the outer layer. I don't know how many layers are left, so I don't know the layer count. Part of that flood of water and reversal could also push this out. So don't just think it's all push this out with the compression coming in. There's a reversal after that great pressure coming in. There's a reverse pressure, and this could be the reverse pressure pushing it into a new position. I don't have that with the metal to the left because the water pressure wouldn't buckle that metal. Like that. Now let's go see what we got. What else for us? It says 55 pages. Shit. I'm going to do this in a couple of groups for you. All right, so we got layer 4, layer 5. So these are 1 inches. Okay. So yeah, this proves what I said. Look, it's like a book, and those are the pages of it. They don't bond, even though they did it together in one section. Maybe that looks like the bottle again. Look in the background. I don't know what the red's for, but maybe we can find an old image and see if we can find red on the bottom of the bottles. I posted bottles a long time ago. It's a beautiful shot of the nut, and it's much more square than when they bring it up. When they bring it up, this seems like it's out of square. When they bring it up out of the Netherlands, and here's that's curly Q, and you can see it's a full 180 twist on there. Full 180 twist. I'm really starting to wonder if this thing spun around. Like I said, spun around. The carbon fiber section spun around. We're now looking at the ring where you lost the bolted connections. All right, this would have been fully bolted on the rear. We got a nice little chunk of titanium missing here. Okay, I don't know where that went or when, but they would be able to tell that looking at how the sheen is if it corroded over. What the hell is that on the outside? That's some white. I'm just looking at the exterior now because we got access to it like this. It's a beautiful high def. Some of these scratches were already there. These scratches like this, they were, BFH in it. Oh, what the hell's this? Look. It's like that. It might be that weld. That's right. They had a weld on this to lift it up. So, BFH stands for big fucking hammer. Just trying to manhandle something there. So this is a different view of the same thing. There's a nut to your right, and here it is here. It would be 2 of them. Okay, so different viewpoint, angle of view. Now we're looking down. Yeah, this would be the tank then. One of the propane tanks. Fuck it, propane tank. I'm sticking with it. One of the oxygen tanks. And now it's buckled. It could also buckle by loss of air pressure, except for that's not how they buckle on the loss of air pressure. On the loss of air pressure, they do this. I've found them in ocean. Image is covered, so this is the critical shear zone. The ends of the bottles are pretty strong. They're closed off, and this buckles down. It flattens it out, the midsection. This is the first time I've seen this type of deformation, and with implosion. And yes, these imploded also, and they look like that. So back to that one, that bottle. I want to say there's a driving force. Be back to the lid. Back to the lid. This is the floor, and so let's move on. Hull piece D, outer surface D, CCW edge. Yeah, CCW, I'm going to look for their graph, but I would think that's counterclockwise. But doesn't make sense. C layer. C layer. Okay, 4 and 5, 2 and 3. Well, I see, it says this is 2 and 3, but I see 1, and then 2, and then 3. They're counting this as says 2 layers. 1, 2, 3, and this should be 4. It says 4 and 5. So then where is our 1? The 1's internal. Oh, they actually don't. Let's see. Nope, they don't say 1. Yeah, the SGT I think is segment. This is so. When you look at that, the one video I'm going to link here, that would be. I think that's what we're talking about. And they do call for 3 segments. Oh, here's layer 1. Okay. Let's go back to that one. See if we can see layer 1. So layer 1, which is weird. So then they're calling this 2 and 3. I got it. I'm a little more smarter now. Going through the image, trying to interpret what they're saying. So this is 1, 2, 3, and I can't figure out. I don't know if there's fiberglass. I doubt it. Here's my bottle again. Yeah, that's just the internal liner coating or whatever they might have used on it. Because they had to slip shit. It had to be a ring to roll everything on, and it might be the release product that you use to release it, to slide out your spandrel. Spandrel, yeah. All right, we saw something like this already, or at least I did. Yeah, and that's your carbon fiber, your epoxies, top layer. As you can see, there's big sections. So I think again, punching shear took place, allowing this to break free. And this is almost end to end. The distance, I'm sure they can measure it, which shows you just blew it off. It just, it came in. But remember, it's coming in 2 directions. As let's say the 6 is there again. It's coming in, and it's not going to favor one side. It's going to try to flood the compartment both directions. So you could get this ejecting off. But remember, the eyeballs in there, it definitely gets pushed away. But at some point, just keep remembering this. If you could slow this down to 1,000,000 frames a second in your mind, at some point, as this breaks through, the rest of this pressure here says, oh, we're now got a void here. This is nothing stopping it from buckling here. There's nothing in there to stop it from us crushing forward now. Because now we've got a punch here, a hole in here. So it says, I got that. The rest of the ocean says, I got this. And it uses this lid as a ram. And it rams back the bottles, the tanks, and rams it into this lid, impacting it so hard that it separates the interface ring, rams it back there, compresses the oxygen bottles, and then the counterforce. Remember, that's a lot of pressure that's created. So maybe it's 5,000 psi, but this thing might have instantly created, let's go to 8,000 psi. There's 3,000 more psi overpressure than exists in the water around it. That 8,000 psi pushes back, boom, explodes back out. It explodes back out, and this settles down into the sand like we see it. And the head dome and the face and the eyeball dome, I like calling it the eyeball. They call it the window. You call it acrylic lens or whatever you want to call it. So this one goes here, and this one goes here. But that bottle didn't get crushed by the pressure like that. That bottle got crushed by the only thing that can compact it would be this. Would be the front dome. Only thing that can the whole entire vessel. There's no carbon fiber that can compress that. The ocean pressure can't compress it that way. It doesn't fail that way. And I'll try to get you an image of that. So it can only be the dome that came in to take care of that job. All right, and we see the end. Let's call it an end. It's an end. So this would be, I think this is a glue, epoxy glue, and in between it, there's no epoxy glue. You look at the way so this imploded, and we could figure out if they knew where this is located. They pieced it back together. This would be how you would figure out what piece you ejected off first, because this obviously landed on secondary on it. You can see it didn't splinter it all to hell like everybody does in their finite element models. They splinter everything to hell. I never said it did that. I always said this is more of explosive action. We can see the sand trail, the sand behind it where it impacted and left its witness marks. Not very hard, not very deep on things. All right. Let's go up to here now. Let's see what we got. I think we did this one already. It looks similar. That's a big piece of hull to the left. I think they're just looking for, we need to find a piece where it's just folded in like this, all right? Where it's just splintered all the hell. And that's your punching shear action. And that would be our beginning, I believe, of a failure. The arm, let's see. 5-layer, but I'm going to race through that. The debris field, I can come back to it. It's really, this might be the location because, well, I'm having a problem because I got a lot of small particles together. A lot of small particles together presentedly. Like these, but I might be leaning this. I'm really intuitive with my thinking, and I'm liking this for the beginning section, the beginning failure. It's not quite the end. I think the end's down here. I think this is a continuation piece, right? And I'm liking this for the entrance point. Maybe I'll change my position, but well, I'm liking that for the entrance point up there where it says B layer 4-5, where they wrote. I'm liking that as an entry point too. It's a clean break. Okay, let's go. What the hell are we looking? Oh, that's that buckle piece. Right, that's my baby. What did they call it? Let's see what they said. So it's buckled, and that's the legs coming in. Not the legs, but the interface ring was still there at the time because it's connected to the interface ring, and it buckled it in. Oh, I gotta go get you the interface ring. You're never gonna get it otherwise. Pausing video and grabbing interface ring. I might have to stop the video if it deletes. Oh shit. Let me just keep going here because I don't want to have to do this again. So yeah, don't worry about that. It would bend. Don't worry about that. I can explain it if I knew where it was exactly. It's just deflection. Okay, we got forward, port rail, aft rail, starboard rail, port rail. Very intriguing because we've already counted for the rails. Aft rail, forward, aft rail, forward. It's reversed. They're flipped over the directions. Port rail, starboard rail. Okay, so this is definitely a switcheroo. Look, here's the looking down. This would be the left side of the vehicle, vessel, and the right side. Here's the forward by this would be the eyeball. I'm going to put the eyeball here. That aft should be down here. It's opposite. And this aft should be there. So when it broke apart, I mean, I'm not quite sure how they oriented themselves to know that. It did that. It did, it's buckling again. So that's those legs coming backwards. Here's your carbon fiber hull. As you can see, 2 pieces of it with radiuses. So what this tells you is that it didn't fail right there. There's no break in it. So you start doing that, and this is going to be more deduction, and then, oh, we're back to this again. What date is this? Because now I know we have to change our dates. This is channel 2. This is on the ring, so I'm going to ignore that. Channel 7 is what I care about. Channel 7. And this should be the amplitude. You see it's pretty calm. It's a little, and the depth is here. So that's at the bottom. And down here and here. So here is at the bottom. Pretty calm. The rest is noisy. Maybe they're dropping weights or whatever. It's at the bottom. Remember, it's at the 250-degree angle reportedly. That's an overlay. We'll ignore that. There. Oh, and the NTSB guy today, yeah. He compared, he said that he did this. Remember he did one of these? And he said he ran his software. Well, if you go back and look at his video, he shows number 80 as what he did, his new graph. But then he compares it against dive number 81. So that's some smoke and mirror shit there. Now, he's got a PhD, and he's comparing dive 80 to 81 and said he ran a graph on it. That's for the public's, you guys not paying attention. And you get mendazzled and boomed, and oh, this is part of the shit he presented. So wait a minute. I remember that graph. And I don't remember that one, but Maybe we'll see that 8081 thing. Let's go forward a bit. No, I definitely don't remember this. Dive 81, gap in data and jumping gauge readout on ascent. So yeah, this is extrapolation, and I agree with this extrapolation that you have tendons. Let's call these tendons that you get a break in. All right, and this doesn't have to be that big. That size looks big, but it doesn't have to be. And he's channel 5. I thought channel 5 was dead. He's got channel 5 readings. Okay, well maybe channel 5 is not dead. Let's see what channel 5 is. Hoop strain, blah, blah, blah. The curves have been aligned using the linear portion. 6 minutes, 27-second gap is important. I didn't know where the... Okay, here's channel 5 again. So there's 5 again. I do like what he did there with the arrows going up and down. I do like his format. He's showing the anomalies, and he try to tie that with his channel 8. It's the one I care about. Channel 6. Channel 8. Was it channel 8 I would cared about then and not channel 7? I keep saying 7. I think it might have been 8. I know when I see the graph, the vessel again. Let's move it. Let's move it. This is channel 2. Okay, that's on the interface ring. I'm going to ignore that. That could be everything from vibration to just me taking a piss, as we know. Yeah. So here it is, as you see. It's, well, that's all cockeyed, isn't it? So that creates a torque. This one, if it's on there, that might just be the, I don't know if it was, yeah, it had to be attached to it, right? I'm guessing. Let's see what it says. Not had to be. But that would create a torque, a whole fucking mess in that whole Baltic connections, the ×3. Tail cone separators resolve the mishap. What? Post recovery after the forward end of the Lars, aft and end of Titan tipped downward. The tail cone separated as a result of the mishap tipping event with the aft starboard corner Lars. What? The tail cone separated? What do you mean by tail cone? Do they mean that little thing that this they don't mean all of that, do they? Because that already shows it has a history of... No, it would be at the bottom of the fucking ocean. It's separated. What do you mean by separated? Oh, man. Oh, let's move it on. No, there it is there. There it is there. And the end zone, too. There's that white part I told you about. And it didn't have a hole in it. I think they put a hole. I recall I remember the hole for the anchor tie down. And so they have the back of this vessel tied down. Oh, I can do that. So they had the back of the vessel tied down. Let's do it like this. Here's the legs. So here's a bracket. And then it like went here to a leg. So here's the strapping. Here's the insulation back here. But right here is a hook. And they tied it down here with a strap. So as this thing goes around and it gets waved and swashed and everything else, what stops it from falling on? Well, this hook. And where does those forces resolve themselves? Well, they got to do it in the bracket and the one bolt up here. That's how it locks down the rear end. This one is not doing much work. I believe it might be touching the legs, the landing gear, but it can't be connected because they can drop the landing gear, so it can't be connected. All right, so the work is being done through this tie down, which is back here, in between there. It looks like that little poop hole, if you will, and then at the top there. So they go down there, and it's tugging and jogging it and snatching at it. Channel 1. Oh, you gotta be kidding me. You ducked channel 6? Here's channel 6. All right, let's see if there's channel 6 there. There's channel 6. All lit up. Let's see the depth. Yep, all red from start to end. So here's 0 ocean depth at 0. And she's just a shithole dive. Just all of it, all red. So that's channel 6. Oh, and there's the dives. 83, 82, 81, 80. So, like I said, somebody in the chat said, no, you're wrong. This wasn't the last dive before this. It did 80 dives, and somebody else said 88 dives. Somebody said like 86 dives, and someone said 88. We're like a bidding war. Google says it was 90 total dives. So if that's the case, This is 7 dives away. This one is 7 dives away, considering this is channel, so this is 82. So dive 82 is red, you see it? So dive 82, so it'll be 8 dive, if they went to 90, I don't know the real answer. It was 8 dives away. So people said the real-time monitoring system didn't work. This clearly works. This told them that it was fractured, that they were pinging from the top to the bottom and back up again. The full range. This is channel 1. See how calm it is? Look at dive. So we need to care about dive 82 on this one. So here's a dive 82. And on dive 82, there's a red signal up here near the bottom. Let's see if we can get one more. Now we know we're looking at different data. Let's go to dive. That's channel 1. So let's check the next. Really? I thought there were more. Channel 2. Dive what? I need dive number to compare dive 82. Oh, he leaves out the one channel I need. Dive 82 is not on here. Well, here's channel 83, and so let's see if it's up here. Okay, so we're back to channel. This is channel 8. Dive 8. Okay, channel 8, dive 82. See the red? So 8 is ringing. All right, so it looks like 8 per his graph. Remember, he ran his own software differently with the same data. And I like his graph. It shows that channel 8 was ringing all the way through. Remember, I was looking for channel 7 over here? Forget channel 7 right now anyway. I'm going to look at his channel 7 in a second. Dive 82 shows the profile of 8 ringing red all the way through. Now let's go to where's that channel 7? Come on, baby. There's channel 8. Ocean depth was only 1,000 feet. On this one, they went 1,000 meters rather. So this is shallow dives, or he's only giving us 1,000 meters? Shit, is he only giving us readings for 1,000 meters? He is. Look to the left. He's not, this is not to the bottom then. This is to 1,000 meters. Channel 5, number 82 is ringing, but this could be the interface ring. I forget what 5 is. I don't even know how he got 5, because I thought 5 was not working. Zachary, didn't we talk about 5 not working? And then he's got 5. He's got 5, no problem. And now he's showing the brown would be dive 81. And this is showing that it's like a pop tendon. It says gap in data. So that would be dive 81 because it's brown. See the brown? And then dive 80 was okay. And the other color behind it also okay. So he took it to dive. So yeah, it's showing a profile of the fracturing if you map it with those coloration and also location, if you can locate where the actual sensors are. So here's a big gap down here, like what he did here. It's a permanent gap. So that would be dive 81, yeah. Okay, see it over there? There's 81 brown. So that was your channel 8, that's gone. But then we have frequency again on dive 82. He's got it lit up everywhere. Okay, so we got that. Let's go to channel 8, lit up. Only 1,000 feet though. He's not going all the way down to the bottom, which is, now this is the full bottom depth on this scale. Oh, come on. It's an hour video now, so let's see if we can fast forward this out, and then I'll get you, I'm going to have to do another one tomorrow for you. Blank pages. All right, blank pages. So here's the part we see buckled. This right here with the holes in it. All right, if this gets disconnected, just so you know, I've got many more. Shit, looks like I got enough to give you like 2 more videos tomorrow if I got time. But this is that connection I told you about. This is version 1 bracket. It's a small, it's how it hangs here and bolted up here. There's a small spine. They eventually increase it to make it more rigid back here. But this is down at the bottom there. That's that bottom part where they orient to. The legs are able to break free. This might be putting pressure on it, but it's not. The legs can still break free from it. It's not connected. So and this is where I said that weld, that they welded something on. Where I saw that, I said, what's this over there? And I showed that image. That's probably the weld there. They did that. And there's that tab. And that's why I said it's kind of weird that they're calling that the top, because it's the back, and yet the tab is on the bottom. So there's the tab. It's clearly on the bottom. There's that weld where they would have welded. Let's go look at that again. So here's the tab there. There's the bottom piece of the legs that one part rests on. Now, I didn't get to see the other side. It could be a tab on the other side also, for help for alignment. I've never seen the other side. Oh, correction, I sure have. Hold, wait one. So this is the tab. And then I talk about that little weld there. So it seems like it's oriented this way. Like there's a weld that they lifted up with the chain. I'm sorry, I paused the video. To bring it over and set it in place. They did this weld bracket as I showed you just a moment ago. So here's the weld, the tab. I don't know if one's over there, but there's the double nuts. All right. So that's on the interface ring, not to be confused. It's not on the dome part, but that is that. I think the weld, when they took this off, the weld was left in place, and that's it. No grinding. Here's where I talk about that when they pulled it out, the Neverlands there, I magnified it. I did a video on this. See, these holes are not sheared, and that was inside the bracket I just showed you. Here are the batteries. I always think they should name them the Titan batteries. There's the reinforced spine in black there. And this is, again, I think it just fell off. And then they were trying to go. They never checked the bolts. They get electrolysis and maybe the wrong bolts, and they couldn't take the load and sheared. 1, 2, 3. Yeah, I mean, that's what it's about. So I told you that there's the bottle that fails a certain way. And there it is. It's off a vessel. I was able to find it at depth, and you can see how the ends, how it folds down. I told you like that, but this, we have it crushed up, buckled in. So the only thing that's on there strong to do that, and it has witness marks to it, is the end cap. Is this little lady right here, the dome. Maybe they can't find the glass because maybe that bottle shattered it. There it is here to your left, mid left. I won't bring it up. No waste of energy. I want to bring up something else for you. There's the new version. That image to the right shows a new version of the bracket. You know what? That one I'll bring up. So this is the part that behind there is the right here is that the bolt, that buckled part. So this was there connected to the interface ring here, segment, whatever they call it, and it was driven in. It buckled this. It drove it, followed it. However you see it, followed it. It followed it to that point, and then whisked itself off to whatever direction it had to continue its journey on to. Let's get away from this. So they went to different iterations of foam. It's different grades, but there's one, and it didn't give them quite the response they needed, and they wound up with this. And someone said something. I said, hey, look, they bolt them together. They don't float like that. There's the bolts, and let's go from there. So in this image, this is the disconnect legs. This is the interface ring, and that's that part that's buckled on the opposite side. Remember, they flip over the directions. They flip them, like that. It's very interesting. So it might have been when this happened, I have it always spiraling out. What if there's a tumble and it shakes them off then? Well, it shakes off two. Is one on the underbelly then, which I don't account for. And inside here are your nuts. That's kind of hard to visually see, but this is that line This one right here, if you go back in the video, you'll find this line right here. It's hydraulic line here. And that's one nut, and then the other one's right in front of you right here. All right, there's some hydraulic line coming out of it. That's the hole penetrations. The tab is not identified over here. Not identified to us here. So there's the bottles in the bottom. As you can see, the oxygen bottles I wrote in the comments there, my own feed there. So it does appear to be red in nature. See the red ends? Green and red. So there's green and there's red. Green, and that appears to be red on the outside edge. So that's your bottles. They got driven from there to there. How did it get there? Well, the ring can't do it. It's got to be the dome. The ring's already wrapped around it. So we get our dome doing that, driving it back there. And doing that, it buckles with the interface ring connected, it buckles this strap. It's behind this this version of the leg supports. It's a different version. They went through quite a few iterations of that. So once again, I said it was used for lifting. So there's a weld, but there's a weld also. But if there was a tab, see that tab there for holding it? There's one over here. He's on it now, so there it is. There is another tab over there. But the weld is a long weld, so that's why I have this as the right side, and that weld. So when they show it on the floor like that, I think I see the weld there and the tab here. So that is this whole thing rotated. Even though he's saying that it's the up and down, the top and bottom, I don't think he's got the orientation correct. I think that the only way that you see there's another one of these on the opposite side, but that weld would be over here, not where the tab is, and then the tab would be here if we were observing it. We're observing a tab and then a weld, so tab and a weld that's removed. So I think the dome, the rear dome, took a rotation also. And they got it wrong on the, let's see if we can find some other indicators, some other witness marks. I think he got it wrong on the, well, he gives orientation, but the dome orientation, I think is wrong. So just look at that, and let's look at it. So if you take the ring was totally separated. See, it's a starboard here. That would be. Here's that part, that tab, all right? So this is the multiple nuts I talk about. Okay, hold on. Tell me I gotta do something. There are the multiple nuts there. Now you saw them in the bottom when I showed you the image. Come on, I'm trying to bring up the mouse. The two nuts, all right? So that would be, as the ring goes, it would be at the bottom down there where I showed you. And then, so that rotated, because here it should be around this tab. This should be around here, around that location, even lower with the tab. But it's up there. So that's that rotation I talked about. It took a spin, and that's why we get some extrapolation that may be wrong. Now on the dome part, so the dome that's the bottom right of the dome, but the ring itself, oh yeah, there's the bottom. So that belongs down here. The dome is right, this tab is about correct orientation, and that dome belongs there. The ring, the segment they call it. Port, hell, they don't call it a segment. It says bottom, okay. We'll go with that. So that rotated, and I always talked about the rotational torque here, and that's why you get the spiraling. Now the back end we got now, so I counted for I told you I can count for every piece of material here once I figure it out, once I get to it. So now remember, so I'm gonna give you one more shot at it. So remember where this is, remember these, all right, and the tab, and the orientation. So it can't be the left side, this has to be the starboard side. This has to be the starboard side of the vessel. So here it is here. That's that tab. There's your two nuts. All right? Your two nuts. It's down by the bottom there. now they're way up here. So that tells you it took a huge rotation. There's the tab. All right, they're about aligned. So you see now that the spinning I'm talking about. I'm going to end this video because it's an hour and 10 minutes long, and I have much more data to give you. And I wish I had a life now because this is killing me. I wish I got paid from YouTube stuff. If you want to help out, please look at the wish list and take care of the kitties. You can do a PayPal. The money doesn't go to me. It will go 100% to the stray cats I take care of. I don't need the money, but the cats, I'll take it for the cats 100%. In other words, I'm sorry, a couple people have wrote me and said, look, this is for you to buy a beer. And I don't drink, but I knew the intent was for me. So if you really want to do that, if you feel that way, it's great. But you're still doing the same love to me if you give it to the cat that just made noises at me. Hi, Max. Hi, Max. I hope they heard you. Yeah, Max. Yeah. So that's Max. That's the one I rescued with the FIP, and he's looking much healthier. I mean, he's 11 pounds and some change. He does a lot of loving. He'd break my heart if he died too. So I got to make sure that he lives. So I hope this is helpful. Again, if you want to help out with the channel, then do the help out with the cats. It's like a $10 thing over there. You can send a PayPal donation. I do use it for the cats, and appreciate you. And I missed someone. Zachary reminded me or showed me that I missed someone that gave a donation in the live chat room yesterday. So thank you. Give you a shout out. I had your name written down because it's a double name. Your name's behind yourself, named twice, like your YouTube name. I'm trying to remember it. Can't recall it, but thank you for that donation of $10. Appreciate that. $9.99, whatever it came up as, like that. Thank you. And again, if you want to help me out, help the cats out. Anyone bitching about the mic? Well, I did put a mic link there, and I also made it so you can pick any gift you want to give me. It says you can allow. I just figured it out only yesterday because I was trying to troll back with people with the mic. It says you can pick any gift you want. So you can pick any gift you want. You want to send me a gag gift, a dildo, which I'm never going to use. That would be a fucked up gift to send to me. But I'm a practical joker, so I would have sent that to somebody. I couldn't help it. That would be me. Yeah, so, or something like that. So you could do the gag gifts. I've got a sense of humor, but I prefer the cat gifts, wet food and dry. Incidentally, I'll put the, I haven't seen you in a while, Carolyn. I hope you are doing great. And yeah, I'm going to, tell us say hello. Tell us how you're doing. Thank you to everybody else. And my man down the way, Phil. Hope you're doing great down there in South America. And everyone else around the world. Take care. Love you. And I'll get you more of the way I work is every piece of material has to be accounted for. Right now, I have a bias. My bias is that punching shear took place at the weakest point, and that allowed the first buckle cause a failure. Then the extra overpressure from the end acted as a piston. That the front acted as a piston, the whole dome literally, and was driven in with the weight, the force on it. Drove the bottles back into the back of it. Albeit it did slide up or slide down from that one ring, slid across the ceiling, or it's wherever number 6 is. I think is our kill point. Now I'm willing to move off of 6. I won't die on that mountain because I let data fall where it is. But 6 is the one making noise. Could it be getting it resonance from by chance by the way they wired it? Is it getting the wire is being pulled on and it's being signaled, giving us a false signal? Yeah, that could do it. That definitely could do it. They could have threw the bottles in there, hit some wire, and as it's going down, it's pushing on the fucking wires all this time. And in reality, we're seeing the master kill, but it's post hoc ad hoc. Just because of one thing, try not to tie it to the other thing. All right, you hear a gunshot, what you think is a gunshot, you look outside and you see somebody laying on the ground. And you say, oh shit, I heard the gunshot, there's the person shot. And all of a sudden they get up and walk away. You put it together. It's ad hoc, post hoc. It's actually a longer saying than that, but you always got to remember your bias that you're putting things together. Maybe you should not. But in this case, I think I'm solid on everything but 6. And with this exact location, I think this thing slid across the floor, compressed the bottles. I showed you how they normally fail without being compressed by an end cap. And love you. Hang it up. Yeah. And Zachary, thanks for a little chatter with me. Zachary's his engineer that we banter a lot. And Pugface Media, outstanding. And for a couple of people I made, today I made, whatever you call it. They can help out in the room now with their, what do you call it? You give them permission to do whatever. So I'm not the only one having permission to delete comments or whatever. It's many of the viewers. And if you feel like you want to do it and you're one of my donators, damn right, I'll give you a position status to do that. All right, take care. Love you. Bye. Oh, anybody wondering how much I make on the channel? Donations, this so far, $260 in the last 30 days. So you know, that's the donations and also the channel views. They don't give me much, and they actually make it so I can't get money because they'll put my content at $17, $37, some crazy amount per 1,000 clicks. No advertiser wants to do that. And then they still put advertisement on top of my channel, even when I say no advertising. And so I'm like, whatever. I can't wait for, I wish Google would treat me nice. Whoever's personally monitoring me, I wish you just let me out of my cage, Let me be free. Let me fly, please. Let me come up in the search engine. Love you. I'm going, yep.